All right, so today we're going to continue with Desmos and doing scatter plots and lines of best fit. We're going to focus on some COVID-19 data. I went on the Massachusetts government website and I just looked at the number of cases in Massachusetts of COVID-19 since Halloween. And I put this data here in this form for you. And your goal is kind of the same as before. And I think I'll have you put your answers again on a form. But basically, what you're going to do is you're going to make the trend, the scatter plot. Then you're going to make the line of best fit. You're going to write the equation, and then you're going to make a prediction. So that's the new part. So I figured I would use our jump data to bring you through an example of how to get all the way to the prediction, and then do the assignment for you that way. So all your answers, I think, will be best if we put it on a form, just like we did last time. So let's take you through that process. So here's the data we collected. This is just, I took the names out, but this is just the data of how tall students were in cohort B compacted math and how many inches they could jump total. So basically, if I want to get to the prediction part, I have to do all that other stuff. So I'm going to Command C. I'm going to go to Desmos, put in my table, Command V, and I'm going to scroll down here. I'm going to write have make a line of best fit, Y1. Oh, sorry, I don't know why I have cap locks on. So Y1, squiggly line, MX1 plus B. Okay. So then I'm going to come down, and I don't know if I can do it here yet. No, won't let me make a table yet. So what I have to do is I have to write the equation in y equals mx plus b form here. So I'm going to write y equals my m. I'm going to copy it just as I see it. Slope is 2.60734. That's so every inch a person grows, they can jump an extra 2.6 inches according to our data, x, and then minus 73.2665. Okay, so now I have my line in there. It's there in red, which pretty much is the same thing as the one in black. And now what I'm going to do, right? So here's how you can use Desmos to make a prediction. So X is the person's, if you look again at the top of the table right here, X is the person's height. So let's say we had a really tall kid in our class that was 7 feet. 7 times 12 is 84 inches. So let's say I wanted to make a prediction of how tall a 7-foot student could jump. So if you press here, edit list, and you add a table to your equation, bam, and there's your table. So what I can do now is just plug it in X, and it automatically will multiply by the slope and subtract the y-intercept in this case. So I'm going to put 84, bam. And so my prediction would be 145 inches. So 145 inches divided by 12, that's about 12 feet. Could a 7-footer hit 12 feet? Probably, right? 2 feet above the rim in basketball. Very, very much likely with that prediction. So you're going to do the same thing here. But when you make your prediction, so on October 30th, when you get through all the data and you write your equation and you put your prediction here, what are you going to put in for X? You're going to put in X, you're going to put in the number X equals 30. So into your table, you're going to have it predict out to 30 days since October 31st, which was Halloween. So I hope this video helps you. If you have any questions along the way, I'll be interested to see what you put in the form, and good luck.